So the last session for the day is Tech in Action, Geospatial Insights for Tech Advancement, Agri-Tech Advancements, Automotive, Cultural, Deliver. Let us now see how automation can precise insights are revolutionizing the way we cultivate and deliver agriculture products. Let's dive into the transformative potential of harnessing geospatial data for sustainability, efficient and agri-tech practices. I would like to call upon Advait Kulkarni, founder of Vasundhara Geotechnologies Private Limited on the stage. Please join me in welcoming Dr. Advait Kulkarni.
Good afternoon to the August audience. Thank you, NASSCOM, for giving me the opportunity of being here and sharing my thoughts. It has been a good day of engaging discussions on tech involvement, on ESG aspects of the story, on human life, and dar ke aage jeet hai type conversations. So, from assuming this is the last, I'll not again, not talk a lot of technology, and being a geospatial guy, I'll not bore you with a lot of maps that don't really make sense because it's at the back end. What I'd like to show, this is where I change. Yeah. What I will show you is how the statistics work in the background, and I'll share a small story. It is just an example of what we did not in India and how adapting the same technology in India is a challenge, but in that challenge lies the opportunity, and how getting it to the grassroots is the real opportunity and can really revolutionize the agri-tech or generally the geospatial technology adoptions. Okay, how many of you are synchronizing with the term geospatial technology, if at all? Show of hands, please. Okay, a very few. Okay, so geospatial technology generally is the use of satellites or drones or location intelligence. So your Google Maps is also a part of the geospatial ambit of things. Your Google Earth is part of the geospatial ambit of things. All your ISRO launches and the satellites that everybody is sending out, the images that are coming through, news पे जो पढ़ते रहते हैं कि Planet Labs के image में ये देखा गया कि चाइना ने अंदर घुसखोरी की है. All those come under the ambit of geospatial technologies. What we do at Vasundhara, next slide. What we do at Vasundhara, we are formed in 2017. Okay. And we have very diverse operations in image interpretation and image processing, not really limited to satellites and drones, but I will focus on that right now. We work with defense quite a bit for the last 2 years. We work with military intelligence and naval intelligence for a lot of things that we will need to talk about later. We work with urban applications as well, and however, the story of Vasundhara begins with agriculture, bringing smart agri-tech and orbital insights to farmers. So we had a very interesting conversation with the Honorable Prime Minister back in 2022. I think that was 15th of January 2022, where I was a part of a think tank group that was formed for giving up some policy recommendations from a startup perspective for the budgetary session that was coming up, and in that we made a presentation which is generally the pitch that I will show to you right now. Yeah. So we did a small project. I'll talk to you through a small project that we did in the United Kingdom. Approximately, we were covering an area of 130 square kilometers. This was spread in south of England, and we had to draw rapid estimates and tentative plans of field operations. This was for the winter wheat crop. I know this is a little off the topic that has happened for the day, but I'll just be as grassroots as possible. So we had to detect which of the farms are growing a certain kind of wheat, plain and simple, right? So we had data of more than 800 farms, which had been, the data was maintained for more than 3 years. Again, 600 farms were to be analyzed. So more than 700 farms to be analyzed, that is the amount of data that we have. Satellites used, don't get into the details. We were using European Space Agency satellites for quick response time and application. What we were doing, as I said, as I promised, I'll not get into maps and image representations, but I'll talk to you about statistics. We monitored the farms that we knew from ground truthing were a specific kind of wheat, right? So you have the vegetative curve. So establishment hota hai, then the vegetation gets stronger, you know, hara bhara zyada ban jata hai. So development stage aa gaya, vegetative stage aa gaya, to badhta hai, and then there is the ripening and harvesting. This is the general curve of the vegetation vitality of wheat of that particular type. Now then we have another target farm that we don't know of, but then we do the cross-referencing between each other, and that's how we find out. So again, wheat farms ka curve hai to your hand, hold on, and then unknown farms ka curve hai. Then you do the cross-referencing, you draw up standard deviations, whichever standard deviation is the shortest is the closest match, and hence those are the farms of your target which you don't know of, right? So this is an important step. Why is this important? This is important for you to classify your geography of a certain crop, and hence draw up efficient estimates for your efficient procurement and pricing cycles, right? The yield estimate cycle, generally when you read about the advanced technologies being used for yield estimation cycles, this is one of the core channels and the core pillars of the yield estimation cycles. What is the application scope of all of this? What did we do this for? We were working with the Surrey government at the point, Surrey local bodies. The accurate mapping of the crops, of the known crops, classification, automated classification of the land parcels. So which of the farmer is growing a certain type of crop without going to the field, saving a lot of time, effort and money, and hence mapping and visualization a larger area. So we are touching, this was the slide given to me by Didin, so I continued with the slide. The reason why, I'll just speak on this a little, why I am sticking to this slide is because it is really touching a lot of people with one touch on one side of the story, so touching lives with technology. Why is this a challenge in India? So can you think about doing all of this very efficiently for any crop that you think of, especially in India, right? If you talk about any cash crop, cotton है आपके पास sugar cane है, आपके पास कोई और crop है, doing that in India is more challenging than doing that in any other country. There are three main reasons for that. A, we take multiple crops in the same farmland. That is actually a very sustainable method and a very sustainable thing that our farmers do inherently, right? So jab sugarcane lagate hain, then we have tur dal ke lines also between sugarcane. Now from a satellite perspective, if I have to classify between lines of tur dal and lines of sugarcane, it's absolutely close to impossible, right? So that is challenge number one. Challenge number two, land parcels in India are extremely fragmented, very, very small. So you have an inheritance of 10 acre, then you have two brothers, then it becomes 5 acres each. Then those two brothers have 2 more sons each. So that becomes 2.5 acre each. Or aise karte karate, I don't know what the fragments are in our hand right now. At that fragment size, for a satellite to observe very efficiently, it is extremely difficult because the variety and the variations within those land parcels are going to be very high. Right? So अगर मेरे भाई ने cotton लिया है और मैंने sugarcane लिया है, तो satellite will not be able to make out the difference because it is going to be it's going to be green at some point, right? So I don't have the spectral dimensions to make those classifications. So I have to depend a lot on statistical analysis. And then the most important point, the challenge that is the biggest opportunity in India, that the data is not structured and it's not maintained in India at all. So the farming data or on-ground data of the cultivation that has been taken is so ill kept that there cannot be a strong statistical model that can be built on any of these farms. The data collection itself has to be a major effort first, then all these modeling will come into play, right? So that is where that is where, so this is generally the story of what we've done with agriculture in one of our problem statement. It was a very good business. The euros came in very well, but to replicate that in India, we came up with a program called Satellite in Each Hand. So we started realizing that until and unless, and this is the reality of any technology, if we are trying to adopt technology in India, until and unless the last mile user becomes an active operator of that technology, no technology is going to have a survival in India. It is not going to be sustainable, nor it is going to be successful. The classic example of this is the UPI payments. Because everybody, even my Fulwala has a scan kept in front of me, because he is doing that, and not just in major urban areas, everywhere, because this is the condition everywhere. That is why UPI is a success story. And that is precisely what is going to happen with every single technology. So the government of India came up with a geospatial policy. The government of India came up with a new space policy. All of you know that space is getting privatized left, right, and center. There are many of our friends who are getting into the furry of, privatizing launches, privatizing analysis, privatizing drones. Everything is getting privatized. But all of that is going to be successful if and only if the last mile user is an active contributor and an active user of the technology. And that is only going to happen when satellite comes into each hand. So I'll just wrap up quickly because I have to make few important points. In this matrix, you will see there is a lot of data that is available. Government has created a lot of data. There's a lot of satellite data which is freely available. Believe me, there is a lot of freely available data. There's a lot of non-geospatial data. जैसे आपके businesses में अभी आप बहुत data maintain कर रहे हैं, बहुत सारे लोग, but you are unaware of the fact that it can be put onto a spatial thought, right? You can have a spatial analysis about it. There is door-to-door survey data ready. Believe me, there's like person-to-person data ready, but it is not being used, visualized, and used for a lot of different applications. So that gap is only purely knowledge gap. And when I say knowledge gap, it is just the awareness gap. See, we are not expecting each and every individual to be knowledgeable to be using it, but at least each and every individual to be aware of it. WhatsApp के बारे में सारे लोग aware हैं, इसलिए WhatsApp successful है. Right? Nobody cares of how WhatsApp is handling the data, how it is handling the encryption. They are just using it as an SMS service. The core tech behind, let the technologists, let us take care of that. But if the market, if the end user is aware of what is happening, that is where the success of the technology is going to come into picture. Where is the immediate impact of my entire user base being aware of advanced technologies? You will have crowdsourced real-time updating data. Imagine an India where you have some sort of a system, an incentivized system, or maybe even gamified platforms where the crop information or crop threats or distress signals are being uploaded as easily as a WhatsApp SMS service, and those are being relayed across the nation like news is getting viral, and that kind of a voluminous data is getting updated each and every day, each and every moment. So imagine how easy the surveys are going to be. Imagine how easy the crop insurance is going to be. Imagine how easy agri-finance is going to be, and it's going to be seamless. One success story that I'll just share with you, I don't have this slide on that, I think. No, but we run the satellite in hand. It's a program that we run very frequently, and we train a lot of people. We have trained more than 5,000 farmers by this point in geospatial technology and mobile technologies. And Wardha नाम का एक district है in Eastern Maharashtra. Wardha district mein, I forget the name of the taluka specifically, but there is a group of villagers who have started maintaining the geospatial data, and there was an animal attack on their crop, and these farmers on their own used satellite images to start creating the the file for Panchanama, and they created their own Panchanama, because of which the entire Panchanama cycle, the entire FIR cycle, and the entire repayment cycle was extremely fast, because the authorities had nowhere to go, because they were ready with everything in hand. The farmers were ready with everything in hand on their own. That is close to what I wanted to speak. Percolation of technology, is the only way of making Atmanirbharta, especially in the tech domains, in the tech adoption domains, and that is where Vasundhara is working a lot in minimizing international dependencies. We are focusing on using Indian satellites. Indigenizing computation process is a major thing that we are doing, and of course making data available democratically, because data is, we are all data points, and we have to use our own data points in a very democratic way. That is the aim, and that is the story that we are sticking to. There's 53 seconds left. I think I can take a few questions. Thank you so much. Thank you so much.
Thank you so much for the session, Advait. I would like to call Rekha Sahu to facilitate Aditya Kulkarni. Thank you, Rekha ma'am and Advait Kulkarni.